Welcome to lesson 16. In this lesson we're going to be talking about performance qualification. So what is performance qualification, or PQ, and a case study of a clean room PQ. So when we look at the V model, we're back to the end of the V model up here, looking at our performance qualification. So performance qualification is testing what our user requirement specification outlined at the very beginning of our process. PQ tests and verifies the correct equipment performance. It ensures correct performance of the system as per the specs, and it verifies that the system meets customers' intended purpose. We define a PQ as the documented verification that all aspects of a facility, utility, or equipment that can affect product quality perform as they intend, meeting predetermined acceptance criteria. PQ establishes that all aspects of the equipment, facilities, and utilities work well together. So does it work as the user required or as the user intended it to? PQ acceptance criteria are set by the user because the user is the best placed to decide on what parameters in the new equipment, facility, systems would affect the product quality. In the case of processing equipment, the PQ will include testing on actual product, so that might be the raw materials, or it could be substitutes, or it might be simulated products. Traditionally, PQ batches imply that the batches will not be released to the market. If the batches are intended for sale, the experiments are more likely to be reflected in the next phase of validation, which is our process validation. PQ involves targeted testing to verify that the equipment can deliver the performance criteria specified in the user requirement specification. Typically, the scope of PQ extends to include the following scenarios. So if you have a new system being delivered and operated for the first time, that is the most common. If you have an existing system in use, but you want to do it as part of a regular maintenance schedule or part of an annual product review to make sure that it is working as it should. You could do it for systems that have been modified to any degree, so that have come under change control. Equipments or systems that would have been used more than they normally would be, so if they've been used excessively for a certain period of time, you might want to rerun your PQ to make sure that they're still okay. Creating a checklist for troubleshooting or analysing deterioration in efficiency or performance, so just for process enhancements. Or after a system has been expanded in order to increase its capacity, so to make sure the increased capacity with no effect on the quality attributes. PQ is often run in conjunction with OQ because there can be a bit of an overlap between them. The actual product or an approved substitute may be used in secondary manufacturing. Solvents rather than the product in API, approved solid substitutes may be used in dry filtration steps as well. Water for injection in biopharma can be used for the liquid stages. So case study 1. So we have looked at all of the aspects so far for how we would approach a validation study for a clean room. So now we're going to look at a clean room in terms of a performance qualification. So if you were to take part in this project and you were to lead it, what would your considerations be, and who would you involve in your team? So I'd like you to take a minute or two to think about that before you move on to the next slide. OQ of a clean room, the case study. So we have done our IQ in our empty room. We've done our OQ with your equipment in it at rest and also as built. And now we are looking at our PQ, our worst case conditions, looking at the upper and the lower limits of our process. So we're going to be looking at the physical and the micro testing of air quality under simulated operating conditions. We're going to be looking at airflows and the movement under simulated operating conditions as well. So the functional testing that we would do is the critical to quality tests. So obviously the things that are really important for quality in a clean room are your particle counts. That's giving us an idea of how clean the room is. Our microbial tests as well, what bacteria are in the area, if any, hopefully not. Keeping pressure differentials between rooms is one of the mechanisms for keeping a clean room clean, to keep any dust or particulates out of the room. Airflow patterns and pressure cascade will be really important as part of your functional test, and they are all critical to quality tests. The challenge testing we will be doing, there will be some bit of an overlap with your OQ in the circumstances. So we'll be looking at the worst case conditions, so looking at your upper limits and your lower limits of your process. So what is the maximum people or equipment load that you can get into the room and maintain your status or your specifications as you need them to be? What is the maximum temperature or humidity that you can have in the room with maintaining your status? What is the capabilities of your process, in other words? How fast can the room return to its clean state if it's been disrupted? So just to have a little review of what we have looked at for our clean room validation through the last few lessons. So we talked during the IQ phase of what we would do in the empty room. We looked at the quality of the room finishes. We looked at the testing of the HEPA filters. We looked at the testing of the pressure differentials between the room and the rooms beside it. We looked at the P&ID drawings, and we looked at the calibration as well. For the OQ, we looked at it as built, and we looked at it at rest, so empty and then at rest with the equipment sitting in it. So for these OQ tests, what we did was we looked at the particular testing again, both your viable and your non-viable, and we monitored those and measured them. We looked at the temperature and the humidity control, and we looked at velocity and air changes in the room. We also checked the alarms and the interlock systems to make sure that they were all functioning correctly. The PQ, what we've done for this lesson, we've looked at our working conditions. So what are worst case conditions, looking at our upper and lower limits for our specifications for the room, and how can we test those and challenge those. So the maximum number of people, the maximum amount of equipment or load in the room, how did it work with that? What was the maximum temperatures and the maximum humidity you could go to while still remaining within specification? And again, looking at our room recovery potential. So all very important factors in the validation of a clean room. So over to you. So what does a performance qualification actually do? How does a performance qualification differ from a process validation? Thank you very much for your time and attention. We'll talk to you again at the next lesson.